So now we move to the next question, which is also based on this one. So it says that consider a counterclockwise circular contour mod z equal to 1 about the origin, and let fz equal to z sine z over z minus pi squared. Then the integral of fz dz over the contour is, now without even doing anything, you can say that the answer is 0 without even doing any calculations. But had there had some other contour been given and had some other function been given, then you need to know what is known as the residue theorem. So residue theorem is given as follows. So if you want to find out the integral of some complex valued function over some closed contour C, then this is given as follows: 2 pi I times sum of these residues. So these are residues, these are the sum of residues, this a minus 1, b minus 1, c minus 1. And how we find out these residues? So if fz is what? Fz is a complex valued function, and this is supposed to be single valued, analytic. So it will be analytic everywhere except, so it is analytic inside so it is analytic inside as well as on some simple closed curve C, which is also the contour, except, so it's analytic everywhere except at singular points. So these are the singular points which are inside the curve C, and these singular points have residues given by a minus 1, b minus 1, c minus 1, and so on and so forth. So what are the residues? Residues are given as follows. So this is how you would find out residues for when your z equal to a is a pole. Pole of order k. So this is how you would find out the residues. But now when you look at your function, this is your function and this is having singularity. Your singularity is at z equal to pi, and your contour that you are given is mod z equal to 1. So if you look at it, this would be minus 1. This is a circle, basically unit circle. This is like your contour is a unit circle, radius 1 and centered about the origin, this radius being 1. So this is your contour and z equal to pi. So if this is 1, then your pi would be like somewhere over here, which is clearly outside this contour. So z equal to pi, which is your singularity, is outside of your curve. It is outside of C. It is not within C. And therefore, your integral over the contour is simply 0. Had your singularity been inside the curve, you would have found it out using this expression. But if your singularities lie outside the curve, then there is no point of calculating anything. The value of the integral would be 0, because the contribution to the integral comes only from the singular points.